Hello there, it's Miss Wilhoit. I just wanted to do a quick review of relations, functions, domain, and range. I know some of you guys feel a little more comfortable than others, but we are having a quiz this week, so I just wanted to give you a quick review of those four things. To start our review, let's look at a set of ordered pairs. 2, -3, 4, 6, 3, -1, 6, 6, and 2, 3. If you were asked to state the domain and range of this set, what would you say? The domain is the x values and the range is all of the y values. To give the domain and the range, you can first list all of the x values and all of the y values without duplicating. So the domain would be the 2, the 4, the 3, and the 6. We've already said 2, so we don't have to list this one twice. The range would be all of the y values, again without duplicating. -3, 6, -1, we've already said 6, and 3. If you were looking at a graph or an equation and you notice that all of the x's have a y value, let's say you make a list of all the ordered pairs that you see on the graph, and every x is on your list, that means the domain would be all real numbers. So for example, 0 has a match, it's 0. 1 has a y, and it's 1. 2 has a y, 2. 3 has a y, 3. 4 has a y, 4. And so forth. Then this is an example of all real numbers. Every x that I can name has a value. Therefore, the domain is all real numbers. You guys can tell I'm at home because you can hear my kid in the background screaming. Another question I have is, what is a relation? Is that set of ordered pairs I gave you a relation? The above list of points is a relation because it shows a relationship between the x's and the y's. In order to plot the point 2, -3, you have to use both the x and the y together to plot that point. Is it a function, you ask? We're talking about that set of ordered pairs again. We're talking about this set of ordered pairs. Is that a function? Well, the given set represents a relation, but there are two x's that are the same. 2, -3, and 2, 3. So because the x's are repeated, it is not a function. For every x, there's not exactly one y. This x value, 2, has two y values, -3 and 3. So because 2 has two possible solutions, the relation is not a function. Notice that all I had to do was check whether the relation was a function, was to look for duplicate x values. If you find a duplicate x value, then that means there's more than one y, and you do not have a function. All right, let's look at this graph. If I asked you to state the domain and range, what would you say? Well, I would start by listing the x values for the domain. I see 0, 0 on there. I see 1, 1, 2, 1.8-ish, 3, 2, 4, 3.5, and 5, 3. And the list goes on and on and on in the positive direction. Since the graph only is in the first quadrant, that means all the x's are positive and all the y's are positive. So the domain would be x is greater than or equal to 0. And in this case, it's pretty obvious that your y's also are greater than or equal to 0 because there's no graph down here in the negative y's. Is this a function? The answer is yes, because each x has exactly one y. There's no duplicate x values. You can do the vertical line test through the graph, and you can see that the vertical line only touches the point one time. It does not touch the graph more than one time for each vertical line. And you could also look at the set of coordinate points that I mapped out, and the x's do not repeat themselves. So yes, this relation is a function. Not all relations are functions. Every function is a relation, but not all relations are functions. It's important that you take note. If you have any questions, come see me during Guided Study Hall. See you soon.